Okay, this is the first Saturday afternoon talk that I'm giving, and I hope that this might be a model for what I'm going to do in the future. So, the talk is entitled The Man Who Mistook His Neuropsychologist for a Popstar, and in this talk, I'm going to take you on a journey through the fascinating world of prosopagnosia and super recognition, which are two extremes of face recognition that we all are part of all the time. Some general housekeeping. If you could make any comments on Facebook, I'd really appreciate it if everyone who's on Facebook could do a like and a comment, just letting me know where you're tuning in from, because that will be really useful for us for working out where we're getting people tuning in from, etc. And I've got some helpers who are going to be harvesting questions from Facebook. So if you could write your questions onto there, at the end of the talk, we will be taking those questions and I'll be answering them. If you're a tweeting type of person, then could you please tweet about the talk? It'd be great if you could. And if you could hashtag the brain guy, that'd be great. And you will see at the end of the talk that I will be telling you about the research participation in our research. So here we go. I always like to get my thanks out of the way first of all, because it's very important that you realize that this talk is content me, but it's also thanks to some amazing people who've helped me a lot. So, and I like to let everyone know who they are. So, Claudia Pulcini, hello Claudia from Rome, who's one of my assistants, who is at the moment locked down with her family back in Rome. Then Andrea, one of my lovely former MSc students, who's back in Dubai with her family. Then we've got Ida, who is a second-year undergraduate student of mine, who is in London with her family. We've got Noah, who's from Switzerland, who is back home with his family, but he's studying in London at the moment. And he's studying with Roz, who was a student of mine about 17 years ago and who is now herself a lecturer in neuropsychology. And also, wonderful Lofty. Lofty is the reason that we're here, really, because Lofty and I were going to be organising some talks, some proper face-to-face talks, I think we have to call them now, where I was going to be giving some talks around the UK, and Lofty was going to help me with those. And then the lockdown happened, and Lofty, being a wonderful, warm and enthusiastic person, said, why don't we just go online? And suddenly these online talks were born. And then the other person to thank is the tooting tutor, Pedro. Pedro is a wonderful PhD student, sadly not doing a PhD with me. I would grab him with both arms if I could. He is doing a PhD on music and how that can help people who've had strokes. And this is a wonderful image taken by his friend Lucy Young, but which has gone quite viral, of Pedro playing the saxophone on his street on a Thursday when we tend to come out onto the streets of UK to thank the key workers of the UK, and this was him entertaining his street. So it's thanks to these people that this talk is happening, and I would like to give my heartfelt thanks to all of them. So, welcome to you, because I know that you're all coming from different parts of the world, and I know, for example, that I've got some of my friends tuning in from different parts of India. So, hello Jwala in Bangalore, and Aparna and her students in Kolkata. I've got Lingani in Botswana, and then my wonderful friends in Peterborough in near Toronto, the Hamiltons, and also Paul and Anne-Marie in Toronto. Lots of friends all over the place. So welcome to all of you. And if your country is not represented on here in terms of a welcome sign, then do let me know, because I do like to be inclusive. And this is the map of where, certainly for the last couple of talks, we've had people from coming from. I know that there's one person in Moscow. Hi, Elena. You're representing a large part of the globe at the moment, but I hope there are other people from Moscow coming, tuning in as well. Okay, so here's an outline of the talk. First of all, I'm going to give you a very quick background on what face recognition is about. And then a major part of the talk is me describing to you a remarkable individual that I've worked with who has what's known as acquired prosopagnosia, which is a difficulty in recognizing faces. So I'm going to spend a decent amount of time on that, because as some of you will have seen from my previous talks, by studying people with brain damage, we get an incredible insight into how the healthy brain works. And so this is why I'm going to spend a decent amount of time talking about prosopagnosia. Then I'll tell you about variations in face recognition across all of us, and something known as the bell-shaped curve, which will then allow me to talk about two extremes of face recognition in the general population. So this is without brain damage. We have people with developmental prosopagnosia, and also people who are what are called super recognizers. And then finally, I'm going to broaden things out to not people at the extremes of the face recognition spectrum, but people who are like you and I, and how we vary, and how that variance is something that can be good, but also something that can be problematic. So, first and foremost, although I'm presenting this research is thanks to an army of students who've worked with me over the years, first of all at University of East London, and the most important person in this list is Scott Miller, who was the first person who worked with me about 16 years ago. I've had various researchers who've contributed to my research, and including Rick Hanley from Essex, who's helped me with prosopagnosia, and latterly Josh Davis, who I work with on super recognition. But most importantly, I really want to say a huge thank you to the people without whom this research would just not be possible. And that's the unfortunate people who've had brain damage and who've ended up with a cognitive disorder, and who therefore come to someone like me to take part in research. And it's an incredibly altruistic thing that they're doing, because they're letting people like myself study them to help us understand ourselves. And they do it knowing that I'm not going to fix them, because I'm not someone who's going to fix brain damage, but they're contributing to research. And David, who he's known by the initials DY, but we've been on TV together, so I know he doesn't mind me referring to him. David is one of them. I know that Sandra is tuning in, and Sandra has contributed to some of my research as well. So, as with anything like this, it's a big team effort. It's not just one person's work. The first question I want us to look at is whether faces are special. And we all use faces, so what is it about faces that is so ubiquitous and that is helping us so much in our understanding? So this is an image from Alice in Wonderland, and here's a lovely passage from it. Here's Alice saying to Humpty Dumpty, "Goodbye till we meet again," she said as cheerfully as she could. "I shouldn't know you again if we did meet," Humpty Dumpty replied in a discontented tone, giving her one of his fingers to shake. "You're so exactly like other people." "The face is what one goes by generally," Alice remarked in a thoughtful tone. "That's just what I complain of," said Humpty Dumpty. Your face is the same as everybody else has. The two eyes, so marking the places in the air with his thumb, nose in the middle, mouth under, it's always the same. Now, if you had the two eyes on the same side of the nose, for instance, or the mouth at the top, that would be some help. But it wouldn't look nice, Alice objected. So from the popular literature from a long time ago, we see what could potentially be the first description of prosopagnosia. And it sounds very, very strange, but it's only when we delve into the skill that we take for granted and we use effortlessly on a daily basis that we start understanding the complexity of face recognition. Now, what I want us to do is to look at this lady's face. What we see here is obviously a lady. So if I'd asked you, is this a female or a male, you would say it's a female. If I asked you whether she's happy or sad, you would tell me that she looks more happy than sad. If I asked you whether she was under 30 or over 30, you'd say she's probably over 30. So when looking at this face, you've told me something about her gender, her emotional state, and her age category. Now, my patient David could do all of that as well. Now, if I asked you who this was, I know I can't see any of your hands, but I know none of your hands would go up because you wouldn't know who this person is. It's not a famous person, but this is my patient David's wife. And David can't recognize her. So David could tell you that this is a lady, that she's smiling, and that she's over 30. But if he wasn't expecting to see this face, he wouldn't recognize that this is Val, the woman that he's been married to for many years. And that is the crux of the work that I've been doing for about 15 years with David and then other patients with brain damage to try to understand this remarkable skill of face recognition. So one of the important questions to ask is, are faces special? And what I'm going to try to do is to demonstrate to you through a number of different ways why we think faces are special. Okay, the first way to do this is by looking at this rather interesting painting. The painting is by a Renaissance master called Arcimboldo, who working a few hundred years ago. He was obviously on some good drugs because he did these paintings, which in this case were made of fruits and vegetables, in another case farmyard, pastoral animals, etc. Arcimboldo created these paintings of the Habsburg emperors or Habsburg family in the Austro-Hungarian Empire, and this one is of the Emperor Rodolfo. Now, there's a reason behind that. We don't need to worry about that reason, but I'm sure you can see quite clearly that this is a face-like structure made up of fruits and vegetables. Now, if I said to you, is this a man or a woman, apart from the Carmen Miranda hairstyle here, you'd probably say that it was a male. If I asked you which direction is Rodolfo looking in, you'd probably say he's staring off this way towards the left rather than towards the right. If I asked you whether Rodolfo looked somewhat happy or somewhat angry, you'd say probably somewhat happy. So what you've done there is you've done what we call face processing. You've told me that there's a face there and you can tell me about gender, etc., just the way that we did with Val. If I asked you to point to the nose on Rodolfo, you would reliably point here. There is a patient in Toronto, studied by an amazing researcher who's like a god to me, Maurice Moscovich, who the patient could do all of that for you. But if I said to you, where can you find a pair on that face, you'd be able to point to that object there. Whereas this patient CK, if you said, is there a pair there? He would not be able to find it. If you said, where is the nose? He'd be able to locate the nose as this thing. And yet when you ask him for the pair, he can't find the same part of the painting. And what you have there with CK is this really remarkable and very rare condition where CK could recognize human faces, but he couldn't recognize fruits and vegetables and other living things. It's a very rare disorder and very debilitating. But what that disorder showed us is that at some level the human brain treats human faces and fruits and vegetables, or any other living things for that matter, differently. So we already have a clue there from this remarkable case study that maybe human faces are treated differently by the brain. Now we know that this happens from lots of scientific work, because of course Archambault was not a scientist, he just happened to be a painter with an interesting view on life. But scientists have been able to show the special nature of faces using two rather interesting effects known as the inversion effect and the composite face effect. And in the first one is the inversion effect. Now, when I'm doing this in front of people, I usually ask people to put their hands up. Put your hand up if you want, but I won't be able to see you. What I would like you to do is to see if you can tell me who this is, but please do not turn your head when you look at this face. Now keep looking at that face, and I imagine that maybe a couple of you knew who this was straight away, and for a few more of you it's dawning on you who this is, and for some others you still don't know. It is, of course, Angela Merkel, who is, I think, at the moment, proving to be the leader of the free world, given that a lot of people who think they're very strong and powerful aren't doing a very good job of looking after their countries during the virus, whereas Angelica is. But that's because she's a scientist and she knows what she's doing. Now, what we see there is that some of you will have worked out that this is Dr. Merkel here, but many of you will not have done so, but will have worked out that this image on the right hand side shows Angela Merkel. The visual information in the two images is exactly the same, and yet people will generally find this one difficult to recognize as Dr. Merkel, and other than recognizing this one. If you don't know that this is Angelica Merkel, then go and learn something, because it's important that we know who our politicians are. So this is the inversion effect, and it's a really strong finding. Now, this is the lovely Scott. Hello, Scott. I haven't seen you for about 15 years, I think. Scott is the person who collected this data on a task of face processing, and NCs means health controls. What we have is accuracy on a task like this, looking at faces upright and faces upside down. And what we see here is what we call the face inversion effect, that when faces are upright, people are quite good at recognizing them, whereas when they're upside down, our recognition drops dramatically. Now, interestingly, with my patient David, that I will introduce you to in a while, we don't get that effect at all. And this is a demonstration of the fact that there is probably something not quite right in his face recognition system. The next effect that shows us how important faces are is known as the composite face effect. Now, in this particular illusion, as it were, what we've done is we've taken two faces of famous people, faces of famous people, and we've chopped them up and put the top half of one person's face on top of the bottom half of another person's face. And here is an example. Now, what we ask people to do in an experiment like this is that we say the top half is of a different person to the bottom half. I want you to tell me who the top half is. Now, some of you will have worked out who the top half is. Now, if I do that, you'll realize that the top half is the idiot who pushed the button on the Brexit thing, which we know hasn't been a good idea. Sorry. Well, actually, I'm not going to apologize. Politics is everywhere, and it's important, and we're suffering for it at the moment. So I don't think I need to be apologetic. But the top half is David Cameron, the former Prime Minister of the UK, and the bottom half is actually of David Beckham. Now, when I show you those two images, those of you who did know that this is David Cameron here, I imagine you will agree with me that even though, again, it's the same visual information, it's easier to say that this is David Cameron here than it is here. Now, I'm not going to go into the theoretical reasons behind that, but this is a very, very, very strong, robust finding that irrespective of which celebrities' faces you use, you would find this everywhere in the world. And therefore, what that suggests is that the human brain is doing something rather special with these images or these faces. Okay, so that is from just you and I, because those effects I've just demonstrated on you. Now I'm going to move on to evidence from people with brain damage to look at whether faces are special. This is a quote by two neurologists from France, which is a patient of theirs who said, "I can tell the difference between a man and a woman from across the street, but I failed to recognize the face of an old friend, and I mistook my mother for my wife." So this particular patient, following whatever the brain damage was, could tell you gender, man from woman, but didn't know who his friend was. And when he saw his mother, he thought it was his wife. So what you've got here are the beginnings of the type of face recognition disorder that people, that neurologists and neuropsychologists have been studying. The first reports of this happened in the 1800s when neurologists who were working with people with any sort of disorder of the nervous or neural systems noticed that they had patients who had very specific problems in processing and recognizing other human faces. It was only until 1947 that someone known as Bodimer came up with this term prosopagnosia, and I apologize to the Greek people out there because I'm going to chew up their language now, but this comes from the Greek root nosia, which is to do with knowledge, and the a before it makes it without knowledge, and the prosop means faces. So prosopagnosia basically means without knowledge of faces, or otherwise loss of knowledge of faces. And it's a very rare disorder if it happens through brain damage. And what it allows us to do is to get this incredible insight into how important human faces are. So this is where I introduce you to David, who was in his 60s when I met him about 15 years ago. And he suffered a massive brain hemorrhage in 2001. And this is a scan of his brain. The scan is done horizontally, as if you're cutting across like this. And as you can see, his eyes are here, and this area of white here is the brain damage. So around where the ear is, above the ear. David's brain hemorrhage nearly killed him, and he was in a coma. They were getting ready to, or considered turning the machine off, and remarkably, he came to out of the coma and didn't have any problem. Initially, he had the types of problems that you would expect anyone who's had severe brain injury to have, but apart from the initial problems he had, most of those went, but one problem remained. He couldn't recognize the little people who were running around the bed in the hospital, and he couldn't recognize the woman crying in the chair next to him. And you've met that woman already. That was Val, his wife, and he didn't know who it was. He didn't know that the little people were his grandchildren. Remarkably, even though he couldn't recognize Val from her face, he said he knew when she was arriving because he could recognize her footsteps. And that's quite an important thing, that individuals with prosopagnosia haven't got an amnesia. They haven't forgotten who the person is. It's simply that they can't recognize them from the face. So this is a video of David and myself, taken a number of years ago when for a program for the BBC. So I'll play this to you to give you a flavour for his own words. Uses things like people's clothing, whether they wear glasses, whether they've got a goatee, etc. So he tends to use information that's classically outside the face.
Everything about you I can see. Say your rimless glasses, your shirt colour of your hair. But it's just putting the facial bits together is difficult. I have difficult describing anybody's face, even though I can see it perfectly.
When David does the same test I did, he fails to recognise even the most famous of faces.
And here,
I haven't got a clue. I should know who he is. Gordon Brown or Prescott. Face doesn't.
But then a photograph brings a reaction.
Is that my wife? Yeah.
Okay, David, when you saw this photograph, you had a bit of an emotional reaction. So what was the reaction?
I wasn't sure if it was her. I wasn't sure if it was Val. And I'll get disappointed if I was wrong. Yep. Because I should be able to recognise the most important person in my life.
Yeah. So what you see there is David speaking about his experiences, and we see that he didn't recognize someone very famous like Barack Obama, but then he couldn't even recognize his wife. He did eventually work out that it was Val, but that's because that is a photograph that's in their hallway and he sees it every day. But he's told me many stories of when they've been abroad and he hasn't known who Val was if he met her outside the hotel. So next what I'm going to do is to show you examples of us doing formal testing with him, where we showed him pictures of famous people, and we asked him to say whether he knew who they were, and if he did, on a scale of 1 to 10, to give us his confidence. So 1 would mean I haven't got a clue, I'm just guessing. 10 would be I'm completely certain of who this person is. Now these videos again were taken about 15 years ago, and this was our Prime Minister at the time, Tony Blair. So let's see what he says with this face and then the face after this.
No.
Okay.
Is that Marilyn Monroe?
1 to 10?
I would say 7.
Okay.
Because of the little beauty spot and the red lips. Don't show red, but you can sort of...
Yeah, right.
I can imagine saying, "Happy birthday, Mr. President."
Okay. Okay, so what you see there is that David eventually says the name Marilyn Monroe, but he doesn't actually say it's Marilyn Monroe. He asks the question, is that Marilyn Monroe? And when he's speaking about it, he says he thinks so because of the beauty spot, the lips, etc. Now, that face, until the Kardashians broke the internet with their selfies, was one of the most photographed faces ever photographed. And yet it took David 7 whole seconds to work out that it might be Marilyn Monroe. He didn't say it was Marilyn Monroe, and he only said on a scale of 1 to 10 he was 7 certain. So he wasn't even certain about this. So what we take for granted that is Marilyn Monroe, it's obviously not the case. Now here's another video, and this face will be only familiar to some of you, but it's worth doing just in case.
It's not Elvis Costello, is it?
Scale of 1 to 10.
Pure guess. Wears glasses.
Okay.
Pure guess.
Now what we see there is that David says that he thinks it's someone called Elvis Costello, who was a singer from the 70s who was known for these very blocky glasses, and he says that he's only guessing it. It was actually, in fact, Peter Sellers, the British actor who was in the Pink Panther, etc. And so what we see there is that David sometimes recognizes people like Marilyn Monroe, doesn't actually recognize them, thinks that he knows who they are, but often he doesn't know who someone is and mistakes them for someone else. Now, in a talk that I was giving just like this during International Brain Awareness Day, David was there in the audience, and I'd shown those examples, and I'd shown his brain scan, then I'd shown the picture of Tony Blair to show that he didn't recognize Tony Blair, and then I showed this face, and I said, and David didn't even know who this person was. And it wasn't deliberate that I didn't use this person's name. I think it was just because I was quite disgusted because of what was happening at the time in American and world politics. And isn't it amazing how times change, that the anger that one had for George Bush is rather muted compared to how one feels about the current occupant of the White House. Anyway, moving on. So I said, so David didn't even recognize this person. Now, the lovely Scott, who'd been working with me, was sat next to David in the audience, and David nudged Scott and said, "Scott, I didn't even recognize myself." And Scott said, "What do you mean?" And he said, "I was just showing a picture of me and I didn't know it was me." And Scott said, "That isn't you, that's George Bush." So what you see is that David took, added up 2 and 2 and got some sort of banana here. He uses the clues that are in front of him, that I was talking about his brain damage. I was talking about the fact that he can't recognize famous people, and then I said, and he didn't even recognize this man. And from the video you saw that David's got a rectangular face, he's a similar age to George Bush, so he just assumed that when I said he didn't even recognize this person, that I was talking about David rather than George Bush. So you can see there that a person with prosopagnosia doesn't even recognize themselves. Now, in a task that we were doing with him, we wanted to look at certain aspects of face recognition, in which we put some photographs of famous people, but also members of David's family, his children, his grandchildren, the neuropsychologist Leslie Murphy, who had referred David to me for research, and a picture of me because we didn't know whether he recognized me or not, and we made sure that I wasn't there on the day that David was being tested in case he got primed by the fact that I was there. So we'd used this photograph, which is a rather ancient photograph of me from the staff notice board at my previous university. When David came to this picture and he was asked for each photograph, "Do you know who this is?" He said yes. And Scott said, "Who is it?" And David said, "That's George Michael." Scott was very professional and didn't laugh his head off. He asked David, on a scale of 1 to 10, "How certain are you that that's George Michael?" And he said 10. That's George Michael. Just for the sake of those of you who don't know who George Michael is, or was, he is the Greek-British singer who was part of Wham, and he died a couple of years ago. Now, what we have here is David thinking, "I'm George Michael." Now, why is that happening? Well, I used to have a gold earring until I clumsily lost it. I have a goatee beard. Right now I can't be bothered because shaving is boring, so I'm just trimming things. I'm Indian, I've got a darker skin tone. George Michael was Greek, so he had a Mediterranean complexion. So David puts these visual clues, the gold earring, the goatee beard, the darker skin tone, and he works out, who do I know who looks like that? Now, remember Marilyn Monroe? He said that he thought it was Marilyn Monroe because of the lips, the hair, etc., etc. So what you see there is that David sometimes is constantly using visual cues to try to work out who someone is, but that isn't how you and I recognize each other. If you were to meet me and you'd seen me a few times, you wouldn't be looking at my left eye, my right eye, my nose, my goatee, etc. to work out who I am. You'd be doing it differently, and we know that because of things like the face inversion effect and the composite face effect. But the types of errors that people like David make, where they sometimes recognize someone from these little cues, shows that they're not visually blind. They can see the face, but somehow they're looking at the face in a different way to the rest of us. Okay, an important question is, can someone with prosopagnosia recognize someone at all? Now that sounds like a counterintuitive question, but we did a study in which we took famous people's faces and we put a white mask over the main part of the face, so covering up the eyes, the nose, the mouth, etc. Now, these were the results for CK, who was the patient in Moscow. I didn't work with CK. This is data that I got from Morris Moskowitz's work. On the blue bar is the healthy controls that we used with CK, and here you've got CK. Now CK only recognized 30% of people if shown this sort of image, whereas the healthy people who were the same age as him recognized twice the number. What you see with David here is that he recognized, that's him in the red here, and these are the healthy adult males that we compared him to. He recognized exactly the same number of people. If these were distinctive people like Elvis Presley, where there were enough cues outside the face to recognize that person. If we'd done the reverse study where we'd shown only the inside of the face, David would have been disastrous at it, and CK would have been the exact opposite. So that shows us that there's a real difference between David, who can recognize faces, cannot recognize faces but can recognize other things, and CK, who's the other way around. So by putting together a lot of information from people with brain damage and also healthy people, we can develop models of face recognition. Now, since this isn't an undergraduate lecture, I'm not going to go into the details, but basically, when we see a face, there's some sort of visual processing that happens, and after that visual processing, we work out the expression that the person is showing, so happy, sad, angry, etc. We're actually doing lip reading. I won't go into that at the moment because it's a bit technical. We do what's called directed visual processing, and again, I won't go into that. And the final thing we do is to work out who someone is. And we know that this is the case because we can have patients who can tell you what expression someone is showing, like David could, but not tell you who the person is. Now, a face recognition unit is literally a photograph that you've got of the people that you know. And that's it. It's just a bank of pictures. Next, you get what's known as a person identity node, which is information about that person. It's my neighbor, it's the person who works in the shop nearby, it's my colleague, etc. Then finally, you get the name generation. And all of this is talking to our cognitive system, which is basically all of our mental processes of memory, language, problem solving, etc. Now, the important thing is you see that external image, and you're seeing me right now, and some of you may have seen a photograph of me before. You do this visual processing, then you compare it to any photographs or images that you've got in your in your data banks in your head, then you pick out, oh, that's that Indian guy, neuropsychologist, and then you work out who it is. And we know that from lots of research that's been done, and this extremely influential model was created by two greats of British cognitive psychology, Vicky Bruce and Andy Young. Now, importantly, this helps us understand ourselves as well. Now, how many times have you been in a situation where you've met someone like the person on the blue person on the left says, "Hey Roger, so good to see you." The other person might be you saying, "Damn, is it Jim, Joe, Jack?" Where you don't recognize someone's name, or you don't remember someone's name. Now, that doesn't mean that you don't recognize the person. It just simply means that you don't remember their name. And sometimes that happens when we're tired. When we're tired, there just isn't enough juice in the system to go all the way down to the bottom. As we get older, some of these processes get a bit weaker. So here's this guy, Ron, or whatever his name is. He's saying, "This is my wife for 42 years," and Lisa has to remind him. Now, that doesn't happen often, but it can happen. And we know that after our mid to early 30s, our face recognition abilities and our remembering of names actually starts going down a tiny bit. Unfortunately, for some people, things get worse, where you don't know who someone is and you mistake them for someone else. And this is something that happens in Alzheimer's, where initially in Alzheimer's, which is a degenerative disorder where slowly different things start shutting down, initially a person, a sufferer, will forget someone's name, just like in those examples I gave you. So they can't remember someone's name. But then the next thing that happens is that this part breaks down and they can't quite remember not the name, but who that person is. And they might mistake their son for their husband. And this is because this part here, the information here has become weaker, and then eventually they don't recognize the person at all. So what these models help us do is to understand how we recognize faces, how people like David, who had brain damage, can't recognize faces, and unfortunately how dementia, etc., slowly breaks down this extremely efficient system. The last part of the talk is the fact that we don't just have to look at people who've got brain damage or people with dementia, etc., to realize that we're not all the same. Now, some of you will know of the bell curve, and the bell curve is the fact that in nature, generally speaking, you have this what we call a distribution, where if you were to do this with heights of trees around you, what you'd find is that there'd be a lot of middle-sized trees, some trees that are a bit shorter, some trees that are a bit taller, some trees that are really shorter, some trees that are really taller, some etc. And so lots of people in lots of trees in the middle, lots of trees getting smaller or shorter. Shorter or taller. We also find this in all sorts of human things. So we find this in our height, where there's an average height and there are people who are taller than average, shorter than average, etc. But most people are clumped here in the middle, and then there's fewer and fewer people as we go further and further away from the center. And that we find in human intelligence, etc., etc., and we find it in face recognition as well. So this is data that was processed by the lovely student of mine, Francesco, of a large study that I did on the online system Reddit, online forum Reddit, where using this task that I've created called the UFMT, we got people on the internet to do this study, and it was a remarkable day for me because in the space of 24 hours I had about 16,000 people do my task. And what we see here is what's called a distribution. So along here we've got the scores, which go from very low scores like 40 through to very high scores, and the highest score you can get on this is 102. And up here is frequency, so it's how many people got a particular score. And what we see is that a lot of people here in the middle got these scores of around 80, which is an average score on my task. There's some people who got low scores, and they might have prosopagnosia. And then we've got some people at the other end of the spectrum who are exceptionally good at this task. So what we see here is a normal distribution of face memory where lots of people are in the middle. Some people are worse, some people are better, some people are exceptionally worse, and some people are exceptionally better. And that's everywhere around us. Which brings me to developmental prosopagnosia. So when I was talking about David and patients like that, what we've got there are people who've had, unfortunately, brain damage due to various different things. However, prosopagnosia can also happen or exist from no known brain damage. There are people who have never found any brain damage in them, yet who have major problems in recognizing faces. There are some well-known people in society, for example, Oliver Sacks, who wrote the book The Man Who Mistook His Wife for a Hat, actually said that he had great problems recognizing faces. Jane Goodall, the famous primatologist, she had prosopagnosia. Those of you who are British and watched Dragon's Den, Duncan Bannatyne from that, who's one of the dragons in that, he has prosopagnosia. And none of these people have got any known brain damage. Estimates suggest that it's about 2.5% of the population. It's difficult to know for certain, but generally speaking, about in a crowd, 1 in 40 or 1 in 50 people may have this condition. Now, we're beginning to do some work in that area, and Claudia, who's going to start her PhD with me, is actually going to be looking at how we can try to diagnose this or assess this much earlier than currently happens. I've met people who didn't know they have this condition until they were in their 40s or 50s, and they heard a nerd like me talking about it, and they realized that this strange term actually applies to them. But all through their lives, they've just gone around thinking that they were a bit strange or different, etc. But it's just a well-known condition. And what you see in the bottom half of the screen is the Facebook group that was created a number of years ago for people with prosopagnosia, on which they can share information, etc. And I know that some of them have tuned in today. Finally, I'm going to move into people more in the middle of our curve. So this is my passport, and as you can see, I look like a terrorist because you have to have a photograph making you look like a terrorist. When you take a passport photograph, you have to look unfriendly and unhappy, etc., etc. Now, when I turn up to, let's imagine someone turned up to passport control, and it was this person here. Not with the cats, because I don't think you can travel with cats like that. Now, what the passport officer has to do is to work out whether this person here is the same as this person here, because, of course, this photograph was taken ages ago when I got the passport done. So that's the task that the passport officer has. Now, you can put your hands up if you want. I can't count them, but some of you will assume that that's me, but it's not, because that's my identical twin Ajit, and that's me on the left-hand side with the other darling cats that we used to have in our family. Now, of course, this was quite difficult for a passport officer to work out whether it's me or my twin in that photograph is a bit more difficult. So I wouldn't be surprised if someone had a problem with that. But a study has shown that Australian passport officers could make up to 15% errors in deciding whether someone was carrying the correct passport. And that's 1 in 7 errors. So on a plane of 200 people, that's a lot of mistakes they could make, which at a time of global security is worrying. Now, part of this, of course, is that who'd have thunk that it was important to check whether people who have to look at faces are any good at faces? Now, if you were well off enough to hire a chef to cook for you, you'd probably check whether they could cook or not. But no one had thought of testing passport officers who have to look at human faces and photographs to match them to work out whether they're any good at face recognition. Now, if they've got prosopagnosia or just they're weak at face memory, then they could be making a lot of errors. I imagine that few of you know that when you go through the electronic gates at passport control, it's not an automated system. What happens is that you slip your passport in, it scans your passport, and you look at the camera, it takes a photograph of you, and there's someone in a booth back there who has to match those two and make a decision. So it's not an automatic system. It does require a human being to make that judgment. Another example of differences is that in 2011 we had social unrest in London, which resulted in riots, and there were 5,000 people who were known to have committed crimes from CCTV footage. Now, the way that the Metropolitan Police would use the CCTV footage was that they got the clearest images that they could from the CCTV cameras, and they published them on their internal systems and asked their officers whether they recognize any of these people. And they managed to apprehend 4,000 of these suspects, which means that they caught 80% of these people from CCTV, which is rather remarkable. Importantly, very expensive face recognition software that the Metropolitan Police had bought only identified one of those 5,000 suspects, and an average officer recognized 3 people. So the average police officer in London is 3 times better than expensive face recognition software, which goes to show one of the things that I highlighted in one of my previous talks, that the human brain is way, way, way better than any computer at the moment. As well as this, what was found was that while the average was 3 recognitions, there's one police officer that I've done a couple of TV programs with who recognized 183 people. And some of these faces that he recognized were really obscure, from obscure angles and really covered up, and yet Gary was still able to recognize these people. So Gary would be on the very extreme right hand of that bell curve that I showed you earlier. And these 2 examples show us that you can have people who are working in jobs which require face recognition, such as the passport officers, who can make mistakes, and then you can also have police officers who can be exceptional at face memory. As a result of this work, the Metropolitan Police actually created a super recognizer unit that they used to catch criminals, and the Novichok poisoning case that happened in the UK a couple of years ago, that the 2 Russian suspects were actually identified from CCTV cameras that were in Salisbury, and tracked the movement of these 2 guys as they went through the streets of Salisbury through very obscure CCTV image, etc. So it was super recognizers that we used to try to work out who these guys were. Now, finally, I want to go into another area which is important, which is that we all differ in our face recognition abilities, but we've also got different faces. And this is a task that I created a number of years ago, where I created faces that were made to look South Asian, Afro-Caribbean, or white Caucasian. And what we wanted to do was to look at whether we're better at recognizing people from our own race than we are from other races. And this is because of lots of stereotypical ideas about people from other races all looking the same. Now, these are the data that we got. I won't explain the actual scoring, etc., but these are our white participants, our Asian participants, and our Afro-Caribbean participants. And in the red is how people were on their own race, so white participants for their white faces, Asian for their Asian faces, etc. And in the blue, we've got how they were for any other race, so for the white participants, is how they were for Asian and black faces, etc. Now, the take-home message from this is that every single race scored better on their own race than other races. So what that demonstrates is that we are better at recognizing people from our own race than other races. Now, I'm sure there are questions on this, so I'm not going to preempt the answers. So do submit your questions. Now, unfortunately, it helps us understand some other things. This is a man called Ronald Cotton, who was accused of raping a young woman in a university campus in the States. The woman gave a description of a black man who she said had raped her, and the police went and rounded up some suspects, and she identified this man as the person who'd raped her. He spent, I think, 20-something years in prison for that. During this time, this man, Poole, he was found to have been boasting about having raped a white woman on a university campus and getting away with it. Now, whereas years ago there wasn't any DNA evidence that could be used because it happened so many years ago, over time they were able to use the forensic evidence and DNA evidence that was still kept, because it is kept for criminal investigations like this. And there's a project known as the Innocence Project in the States, which is to try to do exonerations of crimes like this where there's been a miscarriage of justice, and they can use new scientific evidence to work out whether someone did commit a crime or not. And using the forensic evidence, they were able to show that Ronald Cotton could not have been there when this woman was raped, and that in fact it was this guy called Poole. On the day that this happened and the exoneration happened, the woman was in court and she broke down in tears, because she knew that because of her thinking that all black men look alike, or having mistaken this black man for another black man, she'd ruined 2 decades of someone's life. The remarkable thing is that Ronald Cotton actually forgave her, and this is a photograph of the two of them together, and they've written a book called Picking Cotton. And I feel emotional just talking about it, that he forgave her, and together they've written this book called Picking Cotton, and it's about exonerations from forensic evidence, etc., and about miscarriages of justice. And this shows us that the errors that can happen in face recognition are multifarious, and they're not just for people with brain damage. They happen for us, irrespective of how good or bad we are at face recognition. And also it can happen because of this idea that people of different races to ours look the same, which we know that they don't. Finally, recent work has started questioning whether these super recognizers that are used by the police are infallible. And that is actually another issue that we now have to grapple with, because I often see people talk about these super recognizers as people who never forget a face. That is complete and utter rubbish. These people do not remember every face they've ever met. They just happen to be better than you and I, but that also means that they can make errors, and it's really important that that is addressed. So, as a summary, what we can see is that face recognition is extremely complex and involves many different processes. There's a huge variation in individuals' abilities in face recognition, going from people with prosopagnosia, either from acquired through brain damage or developmental, through to these super recognizers. And the findings from all of these can help us to develop models of how our brains recognize faces, and the findings from research can be used to help people with face blindness or prosopagnosia and in certain aspects of general society. But research is still progressing, and we need to apply with caution about findings and applications, which is why further research is always needed. So, finally, I'm just going to remind you that my research group is very active in looking at a number of different areas, and we look at face recognition, memory and amnesia, dementia, stroke rehabilitation, and something known as executive functions. And if you're interested, then please do email Claudia at c.pulcini@goal.ac.uk, or you can even send in a request through Facebook. So I'd like to thank you for listening to this talk. Do tweet about it if you are. And I'm going to tell you that the next talk is a bit of a mouthful, but it's about the brain of the brain, which is the prefrontal cortex, this area here. So the next talk is going to be about why the prefrontal cortex is so important in childhood development, challenges through adolescence, addictive behaviors, decision making, the aging process, and even the impact of drug therapies for some forms of cancer. Now, depending on the feedback that we receive about whether people would prefer a talk around this time on a Saturday or a weekday evening, we will decide when the next talk will be. So all you people on Facebook, start voting. Let us know what you think, so that we can work out when the next talk will be, and I will announce it as soon as we've received some feedback. So finally, because I'm quite shattered, I'm going to be going outside in a little while. These are my neighbours, Becky, Anna, and the lovely Ben and Sophie, because Ben and Sophie are the ones who actually requested that I talk about super recognition. This is us having a physically distant but socially close dinner party outside last weekend, and Ben and Sophie have invited me out or they're going to open their gin and tonic bar next doors outside, and I'm going to go and have a gin and tonic in a little while. That is after I've taken some questions from you all. So, first question, from my friend Dave from university. Dave has said, a question or observation relevant to the order in which the brain processes faces. At university, there was a woman who I found physically attractive, but didn't get on with particularly well. After graduating, I bumped into her maybe 3 times, and each time the sequence of events in my brain seemed to go, hello, she looks nice, followed by a fraction of a second later by, oh no, it's so-and-so. Does that agree with the expected sequence of processing? Yes, absolutely, Dave, because what's happening is that right now the light is coming from your computer screen. It's taking that information from there of the image of my face. It's going into your eyes, and there's a screen at the back of the eyes called the retina, and that processes the visual information, the very early bit, and all it's seeing is just light. And that then goes to the back of the brain here, and initially all the brain sees is edges, color, and movement. That's all it sees. And slowly it starts processing that information, and it kind of pushes that information further and further forward along the floor of the brain, and it's creating an image. And at some point, when the brain has decided there's a face there, it goes into this special system in an area called the fusiform gyrus, and that's where this face processing happens. Now, the first thing, remember, is this initial processing before you know who someone is. And that's where, oh, that person is attractive, etc., comes in. It's only after that that you get the sense of, oh, I've seen that, I recognize that person. So face recognition happens after that initial processing where you get the gender, the emotion, etc. And what that suggests is that maybe from a biological perspective, attraction was more important evolutionarily than the name of someone. It's a kind of a brutal answer, but yes, you work out whether you're attracted to someone before you work out who that person is. Okay, so the next question, let's see, right. Teresa Mullins says, in terms of cerebral trauma, is someone more likely to suffer face blindness depending on where the trauma occurs in the brain? Yes, Teresa. So, in fact, prosopagnosia is actually very rare from brain damage. And the reason for this is because this area that I just mentioned in answer to Dave's question, called the fusiform gyrus, is quite difficult to get at. It's further in, it's about, let's say, an inch or so in from here. Now, the reason that makes a difference is that to get what we call selective prosopagnosia, where you end up like David, where you can't recognize faces but you're okay at everything else, you've actually got to have a certain amount of brain damage in a specific area but nothing else. So it's no good, well, it's a weird term. If you knock out this whole area over here, you basically destroy the ability to see the edges, the colors, the movement, etc. And people who have very extensive damage back here, they'll have problems with all sorts of visual recognition, not just faces. So to end up with a very selective, as we call it, prosopagnosia like David's one, you have to end up with damage in just this area and not much else. And that's actually quite difficult to get. Whereas the types of brain damage that I'll be talking about in the next talk with the frontal lobe damage, because this is exposed, you can end up knocking the front of the head a lot through lots and lots of different things. So the types of problems that we see from damage to the front of the brain are much more common. So yes, getting prosopagnosia is actually quite rare because you have to end up with damage in a very specific site and nothing else. So that's why it's very rare. Okay, next question. So this is Jwala from Bangalore, who has asked, could you please tell us a little about recognition of other faces such as dogs in people with prosopagnosia? That's a very interesting question, because at the beginning of the talk I was addressing this issue about whether faces are special. Now, it's been debated a lot, and some people have said actually there's nothing special about human faces. And the reason for that is that when I pointed to that pair in that painting, I was asking for you for any pair. I wasn't asking for you for Peter the pair or Percy the pair or Paul the pair. I wasn't asking about specific pairs. I was talking about any pairs. Whereas when you recognize an individual, you don't say which is the human being. You say which is the human being called Ashok. So you're actually having to ask for a specific example of that individual. So some people say you're not actually comparing like for like. So there was a case of an individual who was studied who had been a specialist in birds, an ornithologist, and who could recognize birds from all the subspecies of different types of sparrows, etc., before brain damage. And after brain damage, that person became prosopagnosic, but also lost the ability to recognize different subspecies of birds. Now, what that would suggest is that maybe the problem is that all human faces look very similar. I mean, you saw the picture of me and my twin, but you don't need to be twins to see that we've all got two eyes, a nose, a mouth. The general structure is pretty similar, whereas with everything else, there's much more variety there. Just look at the dog kingdom, for example. There's so much variety in terms of the different species of dogs, etc. So maybe it's just that human faces are so similar that you've just got to have a lot more information processing happening. So that's what some people said. However, that particular suggestion was blown out of the water when a very specific patient was studied in London by two researchers called McNeil and Warrington, which was a bizarre case. And the thing is that neuropsychology is built on bizarre cases, but as long as the bizarre case gives us useful information, we trust it. In this particular case, the patient had been a doctor. I don't know if it was a brain surgeon or a surgeon, but had been a doctor who had brain injury and was not able to practice medicine anymore. And after that, this patient retired and bought a farm, as you do if you retire. And with this farm, he acquired a flock of sheep. Now, remarkably, he was able to recognize individual members of his sheep. So he wasn't saying, that's a sheep, that's a dog. He was saying, that one's Doris, and that one's Peter, and this one's Hilda, and that one's Robert, etc. He knew each sheep's face. And when they gave him pictures of sheep from another farm, he knew they weren't his own sheep. So what that showed is that his inability to recognize human faces wasn't about inability to recognize faces. It was actually inability to recognize human faces, because he could recognize faces of other species. Now, so what that suggests is that there is something special about human faces. There are issues to do with the fact that people who are specialists with dog breeding, for example, are exceptionally good at recognizing dogs, but there are some issues with that particular type of work, just because they've become specialists at that. And we know that when you spend a lot of effort in particular cognitive areas such as memory or things like that, you can get especially good at something, but that doesn't mean that's a natural ability. And we think that the case with faces and this area called the fusiform face gyrus is a natural ability because evolution needed it to be. Okay. So Jane Antoinette Croucher has asked, is there no reliable way for computers to recognize faces? I had no idea about passport control. Now I don't understand why they bother with the electronic gates. That's a good question. I'm not saying that computers will never recognize faces. I'm saying that at the moment they don't. So one of my favorite TV programs used to be Spooks, about MI5 and catching terrorists and etc., etc. Now, on things like MI5, on Spooks and other dramas like that, you often see these computer people looking at images of crowds and computer algorithm picking out a face and recognizing that person. I haven't seen anything that suggests that that's actually possible at the moment. And I mean at the moment, because one day that may be possible, but it's not possible at the moment, not from anything I know. And you saw from the data that I showed about the London riots that this very expensive software that the police had recognized 1 out of the 5,000 suspects that they were looking for. So to me, I'm not at all convinced that this is possible. The thing about the gates is an interesting question. I think that's actually just literally about flow of people, because you can process 4 people at the same time. If you've got 4 people on 4 gates and you've got the officer there. They can have a computer screen with 4 quadrants for each of the 4 gates, and they just click, click, click. And whereas when you're going up to the gate and to the booth for the individual officer, etc., that takes time. And of course, this is only for electronic passports. So I think it's about flow of people through passport control, not because it's a better way to recognize people. Don't sue me if I'm wrong, but that's my take on it. Okay, so Srileka Roy Basu asks, do you find any gender difference issues in face recognition? There are some differences. Women are slightly better at face recognition than men, but not enough such that it would warrant a suggestion that there's more likelihood of prosopagnosia. There's just a slight better performance. But the thing is that, related to what I've just been talking about, face recognition is a skill, just like all things like poetry or running or mathematical abilities, etc. So you can get better at it. And it may be that because of gender differences in the way we socialize with one another, the way we communicate with one another, and knowing that women are better at their communication abilities, it may simply be that women are just better at socializing and therefore learning who people are. And so the differences that we do find between men and women in their face recognition abilities may simply be just that they socialize more and they pay more attention to people's faces, and so they've learned them better. Okay, so Matthew James from Rottingdean down the coast says, is there any chance that a person suffering from prosopagnosia improves using any cognitive exercises like what OTs, occupational therapists, do, or use for suffering from brain damage like stroke? And so is that Edwin? Maybe Edwin, maybe not. Okay, so yes, there have been attempts by researchers to try to find ways of improving face recognition in people with prosopagnosia. Unfortunately, those attempts have not met with much fruit. We've done some work ourselves where we try to use things like the fact that David knew the goatee beard and the gold earring, etc., to try to orient attention, so make him look more towards certain things in a face than other things, to try to get to improve his face recognition like this. But we didn't find any reliable findings. We find little improvements, but not enough such that these things can be generalizable. And one of the things that makes things difficult here is the fact that is what's called heterogeneity. Excuse me. So if we take the fact that even without brain damage, as I showed, we're all different. So we've got that bell-shaped curve. A lot of people in the middle, some people better, some people worse, etc. So we already start off different to one another. Then if someone has brain damage, that brain damage will differ from one person to another. So you end up with damage that varies between two people, person A and person B. They've got different types of brain damage and different sites of brain damage, and before the brain injury, they're already different to one another. So the result is that the impacts on each person tend to be quite different, and so what will work for person A might not work for person B, and that is one of the conundrums in this type of research. And it's complicated by the fact that face recognition is so remarkable, it's so special, all from this. 2 eyes, nose, mouth. It's this triangle here that seems to carry all of the information. Whereas with something like human memory, memory involves so many different things that are involved. It's the visuals, the sound, the taste, your emotions, etc. That we have been able to improve certain aspects of memory. From my last talk, you saw the work that Pedro is doing with stroke rehabilitation, where we're trying to improve the movement of people who have got some sort of partial paralysis, etc. And usually what's happening in those areas, I don't know them well, but usually what's happening is that rather than restoring the function, we're going around it. So we're trying to find ways that we can use a damaged system. But when everything is around here, there's not much else to go around. And so it's, at the moment, I have not seen anything convincing that suggests that we can improve face recognition in people with prosopagnosia to a significant degree. A bit maybe, but not to a significant degree. Okay, now we've got Priyanka Day, who's asked, we sometimes make associations with faces. For example, I like her nose for so-and-so reason, or that her eyes remind me of my mother's eyes, and this can sometimes increase or decrease liking for that person. So in prosopagnosia, what happens to those associations? I'm sure that they still have those associations. Because they can still see. As you saw, David could see my goatee, or he could see Marilyn Monroe's lips, etc. So that aspect of initial visual processing is happening. It's just not going through to the end point of actually recognizing the face as a person, but the associations will still be there. Okay, next question is from Nayanika Sengupta. Why was that patient of yours more able to recognize faces in inverted, unlike the rest of the people? Okay, so that's an interesting question. What Nayanika is asking is that some of you will not have noticed, but whereas when we turn the faces upside down, I showed you that with people without brain damage, they recognize upright faces, like of Dr. Merkel, really easily, but then when we turn the face upside down, it becomes more difficult. With the data that I showed you for David, it was actually the other way around. He was poor at both of them, but he was slightly better at the upside down faces. Now, that might have been just a fluke, or it might have been that there's something there. Now, I think the jury is still out on that. There are some people who suggest that with people with especially developmental prosopagnosia, they have what's known as a reversed inversion face effect, where they find upside down faces easier. It's a rather technical question, and I have an answer for it, but if I answer it now, I'll probably blow everyone else's minds with the complexity of it. So if you want to know the answer, I can give you an answer if you email me. It's just extremely technical, and I would need to have diagrams to demonstrate you the answer. Question from Vivian Boyd, which is that interesting that with everyone wearing facial masks, those of us with prosopagnosia may be at a bit of an advantage. In fact, Vivian, I was thinking that recently, that if those of you who've got prosopagnosia, and I know Vivian does, that you've had to get used to not being able to see all of this, or not recognizing the face as a whole. So if you folk have got really good at things like the shape of the eyebrows, or the exact shape of the eyes, or one eye being just slightly bigger than the other, things that us brain intact or neurotypical, or whatever word you want to use, people in the middle of the curve, okay, the boring average ones, if you've had to get really good at trying to recognize faces by working out that one of my eyes is a tiny bit bigger than the other or something like that, then you can apply those easily in these cases where it's like that. Whereas people who have been using this to recognize me, when you cover my face like that, it's going to become more difficult. So I think that in this situation where people are wearing face masks, I think that in a way, it's going to, let's say it's going to disadvantage you less. I don't think you have you've got an advantage relative to us. I think we're disadvantaged relative to how we are when people aren't wearing masks. So I think that's the way to look at it. Right, I think that is all of the questions. I'm going to see if there's any more coming in, but I think that's a lot of the questions, and that just leaves me to remind you that I've got, hopefully, another talk about the brain of the brain, which is basically the front of the brain, coming up. It may be next Saturday. Depends on whether we're out of lockdown, depends whether I have a date next Saturday with myself, who knows. So I hope that the sound has worked this time. Thank you very much for tuning in. Thank you for my amazing helpers, without whom none of this would have worked. Special thanks again to the lovely Scott out there who helped me with this initial work, which really set the tone for work that I've been doing for 15 years or so. And a preemptive thanks to Ben and Sophie for the gin and tonic that I'm about to go and enjoy. Thank you very much. Goodbye.